In this video, we're going to talk about how to solve quadratic equations by factoring. So remember that factoring helps us identify the expressions that multiply to equal a quadratic expression. So we learned about a lot of different factoring methods, including factoring by GCF, factoring when a is 1, factoring when a is not 1, and some of the special patterns like difference of squares and perfect square trinomials. Remember to review the study guides in the factoring resource folder if you need a quick refresher on how to use any of these methods. So remember, we can also use the zero product property. It tells us that if two expressions multiply to equal 0, then one of them must equal 0. So for example, if we have a times b equals 0, that means that either a equals 0 or b equals 0. And we can use this to solve quadratic equations once they're in factored form. So for example, if we have x squared minus 6x plus 8 equals 0, this will factor into x minus 2 times x minus 4. So since these two will multiply to equal 0, that means that either x minus 2 equals 0 or x minus 4 equals 0. So when we solve these two equations, that's how we get the two solutions, x equals 2 and x equals 4. So to solve quadratic equations by factoring, we're going to start off by setting the quadratic equation equal to 0 so that it has the form ax squared plus bx plus c equals 0. And then we're going to factor ax squared plus bx plus c and use the zero product property to set each factor equal to 0 and solve for the values of x. So remember, when we solve quadratic equations, we can find one real solution, two real solutions, or no real solutions. And it depends on how many times the graph crosses the x-axis. So if it intersects the x-axis at one point, we have one real solution. We have two real solutions if the graph crosses the x-axis twice, and if it just kind of hovers above the x-axis and doesn't ever actually intersect it, we have no real solutions. So let's try now solving this example. So we have 4x squared minus 12x plus 9 equals 0. So it's already set equal to 0, so I'm going to see how I can factor this. Well, I notice here that this first term is a perfect square and this last term is a perfect square, right? This is basically like a squared and b squared. So I'm thinking maybe I can use the perfect squares pattern, the a minus b squared equals a squared minus 2ab plus b squared. Because if a squared equals 4x squared, I can take the square root of both sides and get a equals 2x. If b squared equals 9, I can take the square root of both sides and get b equals 3. So I just need to check that 12x equals 2ab, and so that's 2 times 2x times 3, which is basically 4x times 3, so that's 12x. So that does work, so I can use this factoring pattern to factor this. So I can rewrite this as 2x minus 3 squared equals 0. Well, now how do I solve this equation? Well, I can do that by taking the square root of both sides, right? Because remember, the square root will undo a square power. So that just gives me 2x minus 3 equals 0 because the square root of 0 is 0. I can solve this equation now by adding 3 to both sides. And when I add 3 to both sides, I get 2x equals 3. I can now solve this equation by dividing both sides by 2. And when I do that, I get x equals 3 over 2. And remember, if you want to write that as a decimal, you can write x equals 1.5. So this is going to be a quadratic equation where I have one solution because remember that 2x minus 3 squared tells me that this is a repeated root. So now let's try solving this example. We have 9x squared minus 81x equals 0. Well, the nice thing here is that this quadratic is already set equal to 0, so let's think about how we can factor. Well, since I only have two terms and I notice that both of these are divisible by 9, I think I can factor by GCF, right? So I can factor a 9 out of both terms, and notice that both terms have an x in them. So if I factor out a 9x, I get 9x squared over 9x minus 81x over 9x, and that's equal to 0. So I have 9x times 9 over 9 is 1, and so x squared over x is just x, minus 81 over 9 is 9, and then x over x just cancels. So I have 9x times x minus 9 equals 0. Well, now I can use the zero product property and say that this means that 9x equals 0 or x minus 9 equals 0. If 9x equals 0, I can divide both sides by 9, and that's how I get x equals 0, right? That's one solution. And then on the right side, if I solve this equation, I can add 9 to both sides, and then I get x equals 9. Okay, and that's my second solution. So now let's try solving this example. Well, notice this is not already set equal to 0, so my very first step is going to be to do that. So I can do that by taking this equation. I have x squared equals 11x minus 30, and then I can subtract 11x and add 30 to both sides. So on the left side, I have minus 11x plus 30. And so on the left side, I get x squared minus 11x plus 30, and that's equal to 0. Okay, so this is one of those where a equals 1, right? Because there's no number in front of x squared, so this is where a equals 1. So I'm just going to look at the value of c, right? Remember, this is c, this is b, and then a is the number in front of x squared. So I'm going to be looking for factors of 30, and these factors need to have a sum of negative 11, right? Because that's my value of b. Well, my 30 is positive, okay? So my factors are going to have the same sign, but my b is negative, so the sign on both of my factors is going to be negative. So let's list out now the factors of 30. And remember to use your factor pairs chart if you need help doing this. So we have 1 and 30, 2 and 15, 3 and 10, and then we have 5 and 6. Okay, so we have all our factors, and now I'm going to go ahead and make all of these negative before I find the sums. So negative 1 plus negative 30 is negative 31. Negative 2 and negative 15 is negative 17. Negative 3 and negative 10 is negative 13. Negative 5 and negative 6 is negative 11, so that's going to be the pair that works. So I can rewrite this as x minus 5 times x minus 6 equals 0. Okay, so now the 0 product tells me that x minus 5 equals 0 or x minus 6 equals 0. Okay, so I can solve these equations now. Here I can add 5 to both sides. And so we have x equals 5, which is one of our solutions. And then over here we can add 6 to both sides. And we have x equals 6, which is another solution. Okay. So now you can go ahead and pause the video and try doing this example on your own. So there's actually more than one way to do this problem. One way is to realize that a is 1 and then go ahead and factor by finding the factors of 16 that are going to add to 8. So the factor pair that works is 4 and 4. So we get x plus 4 times x plus 4 equals 0. Well, obviously these are the same expressions, so that we're going to just get one solution, which is x equals negative 4. Another way to do this is to use that perfect squares pattern. We have x squared plus 8x plus 16 equals 0. So notice that this is a perfect square and 16 is a perfect square. So we have a equals x and b equals 4. 2ab does equal 8x. So we can rewrite this as x plus 4 squared equals 0. So then once again, you'll be doing x plus 4 equals 0, which is how we get x equals negative 4, right? This has one solution because that's a repeated root. So now let's try solving this example. So once again, this is not in standard form. So my very first step is going to be to go ahead and rearrange these terms. So I'm going to subtract 18x and 10 from both sides of my equation. So we have minus 18x minus 10 on both sides. So I get 4x squared minus 18x minus 10 equals 0. Well, notice that all of these terms I have over here are divisible by 2. So I can go ahead and actually factor out a 2, like it's factoring out a GCF of 2. And so I have 2 times 4x squared over 2 minus 18x over 2 minus 10 over 2. Okay, and that's equal to 0. So that gives me 2 times 4 over 2 is 2, so I have 2x squared, minus 18 over 2 is 9, so 9x, and then minus 10 over 2, which is 5. Well, now since this is all set equal to 0, I can actually divide both sides by 2, that factor in front, and then those 2's are just going to cancel, leaving me with just 2x squared minus 9x minus 5 equals 0. So now we need to actually factor 2x squared minus 9x minus 5 equals 0. Well, so here's A, and then here's B, and here is C. So if I look at this, I can multiply A times C, and that equals negative 10. So I'm looking for factors of negative 10 that are going to add to my value of B, which is negative 9. Okay, so since negative 10 is a negative number, I need a positive and a negative factor. Since 9 is negative, I'm going to make all of my bigger factors negative. So the factors of 10 are 1 and 10 and 2 and 5. Okay, so if I make all the bigger factors negative, 1 plus negative 10 is negative 9, 2 plus negative 5 is negative 3. So this is going to be the pair that works. So I have 2x squared plus 1x minus 10x minus 5 equals 0. Now I'm going to put my terms into two groups. So I have 2x squared plus 1x plus negative 10x minus 5. And that's equal to 0. So I'm going to continue this now. And so if I look at the first two terms, the GCF is x. So I'm going to divide both of these terms by x. And so let's go ahead and do that. And we get x times 2x squared over x is 2x plus 1x over x is 1. Now let's go to the second set. So if we look at these two terms, the GCF is 5, but we can also just factor out a negative 5 since that first term is negative. So that's going to give me negative 10x over negative 5 minus 5 over negative 5. And that's equal to 0. So we have plus negative 5. I'm going to turn that into a minus 5. And then negative 10x over negative 5 is 2x. Minus 5 over negative 5 is plus 1. That's equal to 0. So the common binomial factor, 2x plus 1, I can pull that out, and then I'm going to write whatever's left on the outside. So we have 2x plus 1 times x minus 5 equals 0. So the zero product property tells me I can separate this into two equations. So I have 2x plus 1 equals 0, or x minus 5 equals 0. All right, so now to solve for x, I'm going to subtract 1 from both sides. So when I do that, I'm going to get 2x equals negative 1. Now I can divide both sides by 2, and so that gives me x equals negative 1/2. Okay, so that's one of my solutions. And then here I'm going to add 5 to both sides. And when I do that, I get x equals 5. Okay, that's another one of my solutions. So now you can go ahead and pause the video and try doing this example on your own. So here we're going to need to first rearrange it into standard form. So we can do that by subtracting 5x and 24 from both sides of this equation. So we get x squared minus 5x minus 24 equals 0. This is a case where a is 1, so we're just going to look at the factors of c, which is negative 24, that add to b, which is negative 5. Negative 24 is a negative number, so we need a positive and a negative number. Since b is negative, we're going to make the bigger factor negative. So when we do that, we find that the correct pair is 3 and negative 8. So this is going to factor into x plus 3 times x minus 8 equals 0. The zero product property tells us that we can do now x plus 3 equals 0 or x minus 8 equals 0 to find the solutions. So we get x equals negative 3 and x equals 8. So remember, you can use factoring to solve quadratic equations as long as ax squared plus bx plus c can be factored. You can use a zero product property to set each factor equal to 0 and solve for the values of x.